If you found this object lying on a table in a dark room, you might mistake it for a video game controller. It's small, it fits perfectly in your hands. It has colorful buttons, glowing lights, and a screen that looks like it belongs on a Game Boy. It looks fun. But if you picked it up, the first thing you would notice is the weight. It is shockingly light. It weighs less than a carton of milk. And then, if someone told you the price, you would probably drop it. This object costs $100,000. For the price of this single piece of equipment, you could buy a brand new Porsche 911. You could buy a house in parts of the Midwest. You could pay for a 4-year degree at Harvard. But in Formula One, this isn't a luxury item. It is the most critical tool in the driver's arsenal. It is the only thing connecting the human brain to the most advanced machine on Earth. This is the Formula One steering wheel. And today, we aren't just going to look at the buttons. We're going to answer the question that every fan asks when they hear that price tag. Why? Why does a controller cost more than a luxury car? To understand the value, we have to stop looking at it as a steering wheel. Because, truthfully, it hasn't been a steering wheel for a very long time. In your road car, the steering wheel does one thing. It points the wheels left or right. It is a dumb piece of plastic and steel. In Formula One, the steering wheel is a computer. It is a mechanic. It is a strategist. It is a lifeline. When Lewis Hamilton or Max Verstappen is driving at 200 miles per hour, pulling 5 Gs in a corner, their body is strapped down so tight they can barely breathe. They cannot reach a dashboard. They cannot look at a center console. They can barely move their heads. So the engineers had to move the entire dashboard, the entire car's nervous system, onto the only thing the driver can touch, the wheel. It starts with the grip. This isn't generic rubber you find at a car parts store. The process of making these grips is closer to medical prosthetics than automotive manufacturing. Before the season even starts, the driver flies to the factory. They sit down with the ergonomics specialists. They put their hands into a special molding clay, gripping a prototype shaft. The engineers scan the exact geometry of their palms. They map the length of the fingers, the pressure points of the thumbs, even the way the skin folds when the hand is clenched in tension. They 3D print a prototype. The driver tests it, and then the feedback starts.
Very similar off the face of it, but Marcelo, you've worked very hard on developing what we have in front of us today. How did it go, and how complicated was the process?
I have to say, it is. They've done an amazing job. Even for somebody like myself that works day in, day out with this F1 steering wheel, to look at this sim wheel, like you actually had to spend like a little bit of time looking at it, actually feeling it, and it's still difficult to really make out which one's which I think is a testament to the fantastic job that they've done in creating this sim wheel.
Shave 2 millimeters off the left pinky, they might say. The clutch paddle is 3 millimeters too far away. They iterate this dozens of times. By the time the final wheel is manufactured, usually wrapped in a bespoke suede or silicone, it is not just a tool, it is an extension of the driver's body. It has to be. Because at 200 miles per hour, if your hand slips 1 millimeter, you are in the wall. But the real cost isn't the carbon fiber shell or the gold-plated connectors inside. The real cost is the complexity. Let's talk about the user interface of death. Imagine playing a video game. You have maybe 12 buttons. X, Y, A, B, some triggers. Now, imagine if pressing the wrong button didn't just make your character jump, it blew up your engine. A modern F1 wheel has roughly 25 buttons, switches, and rotary dials, and the driver has to operate them blind, by feel, while driving faster than a commercial airplane takes off. Let's break down the killer buttons. First, the basics. You have the radio button. This is their link to the world. But it's not just for complaining about traffic, it is for survival. If the car is failing, the engineer needs to tell them how to fix it immediately. Then, the drink button. Yes, there is a pump in the car that shoots isotonic fluid into the driver's mouth. It sounds simple, but in the Singapore Grand Prix, where drivers lose 3 kilos of sweat in 2 hours, a broken drink button can mean severe dehydration, loss of vision, and a guaranteed crash. But those are the easy ones. The real money is in the rotary dials at the bottom. These control the dark arts of the car, the differential, and the engine braking. Let's say you are driving into turn 1. The car feels lazy. It doesn't want to turn in. It's understeering. A normal driver just deals with it. An F1 driver reaches down to the entry diff rotary and clicks it 1 notch. This opens the differential, allowing the rear wheels to rotate more freely, helping the car rotate into the corner. Then, mid-corner, they realize the rear end is sliding too much on exit. So before they even hit the gas, they click the exit diff rotary to lock the differential, giving them better traction out of the turn. They are essentially rewriting the physics of the car, corner by corner, lap by lap. They are redesigning the suspension geometry while driving at the limit of adhesion. And then, there is the most dangerous button of all, the brake magic. This is a specific setting used by Mercedes, but every team has a version of it. And it is the perfect example of why these wheels are so stressful to use. Carbon brakes work best at 1000 degrees Celsius. When there is a safety car, the cars drive slow. The brakes get cold. Cold carbon brakes are like stone. They don't stop the car. They essentially stop working. So, the drivers need a way to generate massive heat quickly. They press the magic button. Normally, the brake bias is set to about 55% on the front wheels. When you press magic, it shifts the bias to almost 90% on the front. It essentially turns the front brakes into heaters. The driver drags the brakes, the discs glow bright orange, and that heat radiates into the tires, keeping them ready to race. But here is the danger. If you forget to turn it off, you have no rear brakes. And if you hit the brake pedal with 90% bias on the front wheels will lock up instantly. We saw exactly what this costs in 2021 at the Azerbaijan Grand Prix. Lewis Hamilton was restarting the race. He had 2 laps to go. He was fighting Sergio Perez for the win. He had the magic button on during the formation lap to warm his tires. He lined up on the grid, he turned it off. He did everything right. The lights went out. Lewis got a better start than Perez. He pulled alongside him. He was about to take the lead of the championship, but as he swerved to the left to avoid Perez, his hand accidentally brushed the back of the steering wheel. He hit the magic button. He didn't know it. The dashboard didn't flash a big enough warning. He arrived at turn 1 at 200 miles per hour. He hit the brake pedal, but the car didn't stop. The front wheels locked up in a puff of smoke. Lewis sailed straight off the track. He went from first place to last place in 4 seconds. That one button press cost him 25 points, and at the end of the year, he lost the World Championship by roughly that margin. A $100,000 piece of technology undone by a single accidental touch. The complexity gets even deeper when we look at the back of the wheel. This is where the secret weapon lives, the clutch. If you drive a manual car, you have a clutch pedal on the floor. In F1, the clutch is on the wheel. But it's not just one paddle, it's usually 2. Why 2 paddles for one clutch? This is one of the coolest secrets in the sport. It's called the bite point find. An F1 car is incredibly difficult to launch. If you drop the clutch too fast, the wheels spin and you go nowhere. If you drop it too slow, the engine bogs down and you get swamped by the cars behind. So, the engineers designed a system to cheat human error. Before the race, the driver goes to the end of the pit lane to do a practice start. They test the grip of the asphalt. They feel exactly where the clutch engages, the bite point. Let's say the bite point is at 42% engagement. The engineer programs that number into the steering wheel software. Now, on the starting grid, the driver pulls both clutch paddles in fully. The clutch is 100% disengaged. The lights turn red. The engines rev to 12,000 RPM. The noise is deafening. When the lights go out, the driver doesn't have to guess where the bite point is. They simply drop the right paddle completely. But the clutch doesn't snap shut because they are still holding the left paddle. And the computer knows that as long as the left paddle is held, the clutch should instantly jump to that preset 42% bite point. So the car launches perfectly. No wheel spin, no bogging down. It is a masterpiece of engineering designed to solve a physics problem in milliseconds. And it all happens in the fingers of the driver. Finally, look at the screen in the center. It is a PCU 8D display, usually made by McLaren Applied Technologies. This isn't just a speedometer. It has over 100 pages of information: tire temperatures, brake temperatures, oil pressure, fuel usage per lap, delta to the car in front, delta to the safety car delta. The driver can scroll through these pages using the menu rotary dials. Imagine doing tech support while driving a roller coaster. Driver, we are seeing a sensor fail on the exhaust. Please go to page 4, turn rotary B to position 6, and fail the sensor. The driver has to do this while defending position, while managing tires. This is why the steering wheel costs $100,000. It's not the materials. You can buy carbon fiber and gold for a few $1,000s. The cost is the reliability. These wheels have to work, always. If your PlayStation controller disconnects, you pause the game. If an F1 steering wheel disconnects, you crash. The connectors, the golden pins that snap the wheel onto the steering column, are military-spec. They have to transmit gigabytes of data while vibrating at frequencies that would rattle your teeth out. The quick release mechanism is a marvel on its own. It allows the driver to remove the wheel in under 5 seconds. Why? Because if the car catches fire, the driver can't get out unless the wheel is removed. That mechanism isn't just a convenience, it is a life-saving device. So, is it worth $100,000? If you look at it as a consumer product, no, it's overpriced. But if you look at it as the nervous system of a $15 million prototype, it is a bargain. This wheel is the difference between winning and losing. It is the difference between a perfect launch and a stalled engine. And sometimes, as we saw in Baku, it is the difference between being a champion and being a runner-up. It is the most expensive, complicated, and stressful game controller in history. And the next time you watch a race, look closely at the driver's hands. They aren't just steering, they are typing, they are coding, they are fixing the car, and they are doing it all while risking their lives. If you enjoyed this deep dive, consider subscribing. We are peeling back the curtain on the business of F1 every single week. And if you think a $100,000 steering wheel is expensive, you need to see how they spend $100 million just to fly these cars to the track. Click the video on your screen right now to watch the logistics nightmare of Formula One. It makes this steering wheel look like pocket change. I'll see you there. Stay dangerous.